Hello, welcome to Layers with Larry. I'm Larry, and these are all my layers. Well, welcome to this episode of Layers with Larry. We're going to focus in on some of the layers low down on my layers. In previous videos, we've covered Precambrian and the Cambrian. Today, we're going to go into the next part of the Paleozoic, three areas, three layers: the Gallatin Formation, the Bighorn Dolostone, and the Madison Limestone. These are deposits laid down in warm, shallow seas. Well, in fact, oceans have existed here in the area we call Cody since 570 million years ago till about 70 million years ago. So most of the history of the life on Earth here in the Cody area is in the ocean. Now, when I say these are shallow oceans, we're talking about 100, 200 feet deep. Conditions very similar to that like you'd find off the coast of Florida today. Very warm, fairly shallow, except when there's hurricanes, very calm. Not a lot of sediment washing in from mountains or the land. And so most of the sediment that collects at the bottoms of these oceans is mostly made up of the shelly parts of creatures that lived in those oceans. And also, if you've been to Florida, the water looks kind of milky, white looking, and that's actually calcium carbonate, the same stuff shells are made out of and your bones are mostly made out of, that's precipitating or just crystallizing in that water, and it just settles to the bottom. So limestones, like this piece of limestone from the Bighorn Dolostone, as it's called, I should explain that. The Bighorn Dolostone used to be the Bighorn Limestone, but it got altered a little bit. Calcium carbonate is the main substance that makes up lime or limestone, but over time, some of that calcium can get substituted with magnesium atoms, and it makes a stone called dolostone or dolomite. And it's harder than limestone. It doesn't fizz in acid quite as well, if you remember the acid tests that I did with the limestones before. With a microscope, if you look at this very carefully, you can see some big things. These are actually corals, horn corals, we'll talk about in a moment. But almost every little bit in here is a piece of a fragment of a shell or a piece of a creature called a crinoid. This is a stem of a particularly large one. They're called crinoids because the word literally means lily-like or plant-like. If you saw this, you might think that that was a plant. Sort of looks like a flower on a stem. Actually, it's an animal. It's related to starfish. This one lived in the Mississippian time. A lot of crinoids lived during Mississippian time, and we have lots of bits and pieces of them in the rocks around Cody. This part up here is the main part of the animal, and these are arms up on the top that it could open up and it would filter feed, catch tiny particles of food and pass them down to its mouth, which was up here on the top. So you can imagine how big this guy was. Some of these things got to be like 20 feet long. And many of them were attached to the ocean bottom by structures that kind of look like roots. So they really look kind of like a plant, look like they had roots and a stem and like a flower thing on top. Here's another kind of echinoderm. You'll recognize right away. It's a very old one. It's like 450 million years old. Ordovician, again from North Africa and Morocco. And you can see a couple of different starfish well preserved on this slab. Now, if you remember back to the episode on trilobites and the Precambrian period, we talked about how when the oceans first rushed in onto the early North American continent, some 550 million years ago or so. It came in very strong currents, and the deposits laid down were very coarse. That was the flathead sandstone. Then as the oceans got a little deeper and a little deeper and a little calmer, we got muddy kind of deposits that made up the formation called the Grovant Formation. Well, we're going to start today then with the next layer above that, which is the Gallatin Formation. It's even for calmer waters. Instead of being sandstone or shale or mudstone, it's now going to be more limestone-like stuff. Here's an image taken up the canyon where you can see at the bottom the layer of the Gallatin Formation, and above that, the Bighorn Dolostone, which is not very thick. And then above that, a very thick section, and that's the Madison Limestone of Mississippian age. Here's a piece of Gallatin Formation, for example, and in it we can see it's very limestoney looking. If I drip acid on it, it'll fizz, trust me on that. But we see some strange features here. If you go up the dam road and you look at this deposit off the side of the road, you'll see a lot of the pieces have these little things that look like pebbles. And somebody who knows some geology might think that's a conglomerate. And in a way it is. But there's also some other features. And if I show it close up, you can see little lines. These are burrows that were made by creatures that were burrowing through this soft, limey mud. And occasionally, these look like they might be fossil shells, but actually they're called rip-up clasts. And they happen when strong currents occasionally would happen, could be from storms at sea, that would stir up the ocean bottom, and photosynthetic bacteria were living on that surface. You remember in the stromatolites we talked about in a previous episode as well. Many stromatolites are just flat surfaces and they bind together the mud. Well, if those strong currents come along and they rip up that partially bound sediment into pieces, and those pieces kind of get banged around and get rounded, and then once settled to the bottom once again, you get that. So that explains the look. And it also explains why we don't find a bunch of complicated fossil remains like trilobites and other stuff, because if there were any here, they just got all ground up in the process of getting mishmashed in this stuff. But the kinds of life that we find in these deposits are, not surprisingly, sea creatures, some of which you kind of recognize, things that look kind of like clams, some things that clearly look like snails, recognize we still have today, are gastropods. A lot of what you find in those early deposits in the late Cambrian and the beginning of the Ordovician and into the Mississippian are things like this. They have various shapes to their shells and various levels of decoration and such. But these are all things called brachiopods. And they look kind of like clams, and they kind of live like clams, but they kind of don't. They lived a long time, and they were very successful during the Paleozoic, especially the early Paleozoic, and but eventually true clam-type things, or bivalves, or pelecypods is another name for them, took over and kind of pushed them out of the scene. Today, there are still some brachiopods alive, but they are nothing like they used to be in the past. This is a really cool specimen, because if we get a close-up view of this, I'll show you inside. When this mud covered up these shells, no mud got inside the shell. The two halves were completely closed up, and so the inside was a cavity that could form like a geode-type structure. You see crystals of calcite inside there. The other common fossil we find in these late or early Paleozoic rocks, the Cambrian and the Ordovician, are trilobites, our favorite little bug of the sea. Don't have any around today, of course. They're extinct, as you saw from the previous video we did about them. But here in the Ordovician, or rather in the late Cambrian, they typically looked a little bit like this. Now, this is a pretty special one because it's very large. Imagine being the person that was digging in the Atlas Mountains in Morocco in North Africa and knocked this piece of rock out and split it open, and inside was lucky enough to find this beautiful trilobite. You can see the head region, the eyes, the middle or thorax region, and the pygidium or the tail. Some of these got to be almost 2 feet long. But as we move into the Ordovician time, and that's roughly about 450 million years ago, the Cambrian ends about 500 million years ago, you get things that are more typically like this. This is a very typical Ordovician age trilobite. Not a lot of decoration or spines or fancy features, but it's have well-developed eyes. And again, you can see his head and his thorax and his tail. And they, like we learned in the previous video on trilobites, can roll up into a little ball to protect himself. Some trilobites in the Ordovician got pretty fancy. And look at this guy, Selenopeltis, from the Ordovician, again, of the North African region of Morocco in the Atlas Mountains. Very elaborate, highly developed spines coming off of each of the segments. Pretty incredible looking things. And then probably the most advanced sort of trilobites develop in a period of time kind of between the Ordovician and the Mississippi. And if you look at my layers, or you look at a table showing the different layers in this area, you'll find that 2 big areas of the Paleozoic are missing. After the Cambrian period comes the Ordovician, but after the Ordovician is the Silurian, and then after that, the Devonian period. And in our area, the Silurian and the Devonian are not represented well. There's no Silurian rocks whatsoever. They just either weren't deposited, or if they were deposited, they got eroded away before the next layers were piled upon where they used to be. There are some Devonian rocks around here. You can see some out in the Beartooths. But during that time, some really elaborate trilobites developed, like this one. We saw him before in the trilobite video. Had those very fancy compound eyes. And they did go into the Mississippian period a little bit, but the Mississippian and the periods that followed it leading to the end of the Paleozoic, it was the beginning of the decline of trilobites. Their diversity decreased, their variety decreased, and eventually 250 million years ago, when the Permian extinction happened at the end of the Paleozoic, all the trilobites were lost and they became extinct. And their place was taken by things that we have today, arthropods or crustacean type things with their shells on the outside, the insects on the land now that we have, and crabs and shrimp and lobsters and stuff like that.